All right, so I did my presentation on ozone non-attainment in Louisville, Kentucky. The ozone event happened on July 6, 2020, and it was levels of about 75 parts per billion, which is about 5 parts per billion higher than the next standard set by the Clean Air Act of 1970. And then the subsequent revisions every 10 or so years. So what I used to determine kind of what was going on in Louisville and come to my conclusions of what was happening was I looked at the emissions monitor in the Louisville area, and then I compared the ozone levels to the NO2 levels, because NO2 is a component or a reagent or of NOx, which is also a reagent of the formation of ozone, which is NOx, VOCs, and sunlight creating ozone. So I looked at the overall NOx levels compared to the ozone levels, and they, for the most part, there was a small correlation between the two. The NOx levels went up and then the ozone levels went up. And then in addition to that, I looked at kind of the weather patterns, because when looking at ozone, you want to know kind of if it's hot out, if it's sunny. So I looked at the weather. The weather was about, high 90s, kind of low 90s in the time. Probably at the time of the highest ozone was probably close to 94 degrees. And so it's great that it's hot out, so there's enough energy, but it was a matter of, or was there cloud coverage or not? So I used the aerosol optical depth from NASA's Worldview to, one, look and see if there was clouds over Louisville at the time, and two, NASA Worldview is pretty good at seeing NO2, which is again part of NOx, and see if the levels are higher, because you can't see ozone with aerosol optical depth, because ozone is invisible, and it's not technically a fine particulate, so it won't scatter and or refract sunlight. And of course, in the NASA Worldview, there wasn't cloud coverage, and we can see that there was a red sort of in the Louisville area / northern Kentucky, and so I can assume that the ozone levels are probably higher because there's no cloud coverage. I also looked at a high split model for the area, and the high split model showed a couple things. One, the air did not move very far on that day. And two, the air was moving from the southwest, which is most of where the industry is in the Louisville area, because that's on the way down to Shepherdsville and more sort of metropolitan areas in the Kentucky area. The only other metropolitan area near Louisville would be probably Cincinnati, which would be northeast. And with what our high split's showing us, it's more than likely that none of the air would have been coming from that direction. So in conclusion, I determined that it was just a normal combination of factors that led to a elevated ozone level. And ultimately, ozone decreased, and eventually the air became safer to breathe due to just dispersion, and more than likely there was cloud coverage the next day or 2 days after, and so it was harder for ozone to build up, and then due to just its lifetime, it slowly disappeared, and eventually was no longer violating the Clean Air Act. And so that is my semester project.